All right, well, we'll go ahead and get started. Thanks everyone for joining us today for the fourth in our 5.4 Informer webinar series. My name is Brad Leupen. I'm the Chief Technology Officer here at Intrinsic. I've been working at Intrinsic and with the Informer product for a couple decades now. So today's webinar is about putting big data to work for you with Informer. And so just talking a little bit about how Informer allows you to not only use it for ad hoc queries, but to also use it for large-scale analytics against much larger data sets. So we're going to start off with a few PowerPoint slides where I'll talk you through some ideas, and then we'll flip over to the browser and I'll show you some examples of some of the things we've been working on to help facilitate working with really large data sets. So Informer has evolved a lot over the years, as many of our customers know. We're now on several years into Informer 5, and over that time it has evolved from an ad hoc query tool with rather limited database support to now an ad hoc query tool and a large-scale analytics tool that allows you to pull data from multi-value data sources, SQL, and now even the web. You can connect to the web to pull data and bring all this data into a unified platform where you can do small scale and large scale reporting. And so I'm always impressed when I look at one of our partners in particular has a production Informer deployment with several billions of rows of data indexed into Informer that their users are consuming every day through Dataset views and templated output and pivot tables and charts and all that. So it's really exciting to see Informer driving so much data into onto the desktops of their end users to be able to be consumed in a way that makes sense for them and solves real world problems. So as we started really trying to ramp up the size of the data set that Informer could handle, there's a lot of challenges with pulling that much information into a reporting tool. For one, the tables that you're querying and joining onto, they're very big. So there are millions of rows of data in these tables. And so even if you're just pulling millions of rows out of a single table, that query can take a really long time to run. And while that query is running, it can be interfering with people's ability to interact with the database. So sometimes it can be affecting write performance into the database, for example. And that's just with one person running the query. But if you're turning users loose on running multi-million row queries throughout the day, that just doesn't scale very well from your database's perspective. There's also some technical issues, particularly when you're joining two tables together, and you might have a where clause that is looking at data coming from one table and a related table. What can happen is when you're joining these two tables together, it works fine for a few thousand rows, but once you start scaling it out into millions and millions of rows, suddenly the amount of memory and compute that it takes to just process the joins can be prohibitively expensive for the database engine. So it can be tough to just get the data out of the database and into a reporting tool to begin with. So you need to sort of think about that. And so with Informer 5, we knew we wanted to support larger data sets or larger reports for our end users to be able to do dashboarding and analytics in addition to their ad hoc queries. And so we felt like this data set idea really helps you to frame how you think about some of these large queries. So one thing that it does is it encourages you to build curated views onto these really large transactional tables. So one of the beauties of the ad hoc query engine with an Informer is you can kind of turn your users loose to some degree. You can give them access to tables, and they can begin writing their own queries, and they can start pulling fields from related tables, and that all works really, really well until you're talking about millions of rows. And so in those cases, it makes sense really for somebody more familiar with the database and how it's indexed to spend a little time testing out the query and making sure that it's doing the right thing and it's not over selecting in terms of rows, and that the joins are being done in a sensible manner. But they can create these kind of curated data sets and then share out access to those. And that way your users can interact with the data and solve reporting needs without, tearing up your transactional database. Another nice thing about a data set is you can ingest it in bulk, and we'll talk about that in a minute, but there's some tricks you can do to get all of the data into a data set. And then once it's there, you can update the data incrementally. So you're not having to refresh this massive thing, every night. You can pull just the new rows that are being added to your transactional system. You can just pull those and bring those into the data set. But some other benefits too. One is it provides consistent data across users. So if your ad hoc query is short, if I run a report, I can ask my colleague to pull the same report, and we'll kind of look at the same data because the report doesn't take very long to run. But if I run an ad hoc query and it brings back 20 million rows, and then I ask my colleague to do the same, we're probably going to be looking at two different versions of the results because the transactional data is likely to have changed in the interim. If we standardize on a data set as a way to deliver that data, if I'm looking at it and my colleague is looking at it, we're both looking at the same data from the same point in time. So it's providing consistency across your end users. In order to allow, though, your users to be able to safely consume this indexed data, you really need some way to be able to safeguard access to the different data elements. So that could be securing data at the row level through a row level filter, so people aren't getting into records that aren't related to their job function. But it may also mean column level security in the case where you may have a data set that contains PII, personal identifying information, that some authorized users can see, but others cannot, so like social security number. So we've been adding some functionality to 5.4 to help facilitate that. Other benefits of data sets, users can filter and aggregate without locking up the transactional database. So they're kind of like a really nice sandbox that you can build this view, as I like to think of it, like an indexed view where you've pulled in a lot of different columns that could be used to satisfy a variety of use cases or answer a variety of questions about the data that is contained within the data set. But once you've done that work up front, your users can really safely interact with that data without fear of degrading the performance of the transactional database behind the scenes. So those are some reasons why we feel like data sets provide a really good platform for interacting with really large data. So I mentioned before, it can be difficult to get all this data into an Informer data set in the first place. So the partner I mentioned, we were looking at how are we going to ingest years worth of data, and we're talking, tens of millions of rows into an Informer index in a way that won't take, a week to do it. Running one query going back years and pulling all those rows, it'll take a long time just to stream that data, but it'll also take a really long time just to do the complicated joins that we need to do across those multi-million row tables. And so the solution that we came up with was to, rather than try to take one massive bite of all this data all at once, but instead to break it up into much smaller bytes, where we could consume these smaller bytes in parallel at the same time. And so it so happens that a lot of the really large data sets that you'd like to build are often kind of transactional in nature and have some kind of date on them. And so what we're able to do is partition, let's say we have a query with 10 million rows, we're able to partition that into really small chunks. So here in this example, we're doing a partition by year. And so we have a command line tool with Informer 5. Many of you maybe didn't know that, but we have a command line tool that you can install that will let you do a lot of things with an Informer 5 instance, like look at logs or pull data. But you can also set up an ingest server that will help you do just this. It'll help you chunk up a really large extract into little pieces and then run them all in parallel against, usually it would be done against a multi-node Informer backend, like a cluster. And so we're able to do that to successfully ingest millions of rows in a relatively short amount of time compared to what it would take to just do it row by row. So, this takes us to getting data into a really large data set. And so what I want to do now is flip over in my browser and walk through some of the new features that are in Informer to help you and your users be able to consume this data and make sense of it, and just some best practices for how you can set up sharing. Okay, so here I've got an Informer 5 instance running, and I've ingested data into my Chicago crimes database. This is 7.4 million rows, and it's about 2 gigabytes in size. I've also built a really wide data set, well, pretty wide. So one thing that we ran into in the field when working with these large data sets is, as I mentioned, it can be a good practice to over-select the data that you bring in. So you might be bringing in, if you're bringing in users, you might be bringing in their names and addresses, but then you might also want to bring in related information from other tables, because you're building a one-size-fits-all view, you're not exactly sure, or there might be a variety of reasons why people would want to consume that data. So people tend to bring in a lot of different columns into a really wide data set. So one thing we found working with our users is that people were spending a lot of time in the system just doing this, where they're like, all right, I'm trying to find this one particular field, where is it? And you're just scrolling left and right, trying to find this certain column. And so we got tired of watching users do that. And so one of the things we did is we went through the system and we identified everywhere where we prompt the user for a field. And so that could be interacting with the grid, it could be building a filter, it could be using pivot or our different visuals. And so we made sure to go to all of those different places and change all of those choosers from being drop downs where you have to scroll and scroll to searchable dialogues that let you very quickly navigate to the fields that you're interested in. So here I've got a bunch of fields in here. This is really only 50. I've seen many data sets with hundreds of fields, so it can get pretty unwieldy. But let's say I have a use case where I want to send out a mailer to my customers, and so I want to pull their names and addresses. Instead of hunting around, I can just start typing. I can type in name, and address, and city, and region, postal code, and country. And I can type in multiple field names up here, and you can see how it will filter the results out. So what I can do is I can actually, let me do this. Let me clear everything out. So I'll clear my grid out and I'll type in name, address, city, region, postal, and country. And then I'll just go through each one of these and just start pulling them in. So I can, depending on what my need is, I can very quickly change the view that I'm looking at. Even if I have hundreds of rows, in the data set, or sorry, hundreds of columns. I can also reset my view at any time to go back to how it was. If you're looking for numeric fields, as is the case often, you can click on numbers up here. Let me select everything. There we go. So here are my numeric fields. Here are my text fields. So I can change by data type to very quickly find what I'm looking for. So, we have this new panel on the column chooser, also have it on the filter bar, lets you quickly search for different things. And then we also have it available on pivot. So if we go into our pivot table and we click on rows, this is searchable too. So I can search by country, and then you can actually do multiple selections here, and then click apply, and then it will apply your choices all at once instead of kind of updating, because sometimes these pivot tables can take a moment to update if you're querying really large tables. So you can pick all of your fields at once and then click apply. Same thing with the values. The different types of aggregations you might do are all grouped underneath the different types of columns. And so these are also all searchable. So a lot of work has been done on those. So hopefully that'll make your lives easier if you're consuming data sets with large number of columns. But back to our crimes example here, I've ingested 7 million rows into this index here on my laptop. This is something with Informer 4 would have been much more difficult to do. This data would have all been sitting in memory on the web server, which could, eventually you kind of run out of memory to be able to save this result. But as a user, I can interact with this data. It still performs really well, which is nice. All of our visuals are set up to allow you to aggregate data, whether you're aggregating thousands or millions of rows. If I click on date here, I can take my trend chart and blow that open and see all 7 million rows very quickly summarized. If I change to area and then I split by, say, location, I can do that, and I can also very quickly go in here and filter this out. And so this will perform a distinct select and bring in the different types that I can click, and then that will then filter the data down. So as a user here interacting with this large data set, it really performs the same, as it would in a much smaller scale. So users able to consume analytics off of it just as easily. One thing, though, we noticed is calculated fields are a very powerful thing within Informer 5. So I know many of you out there have probably used flow steps within Informer to create calculated expressions or calculated columns that you add to your data set. So these would be data elements that aren't stored in the database, but are calculated at runtime as you query them. And those are really handy for many different use cases. The problem we ran into, though, is once you have data that you begin updating incrementally, you're not necessarily refreshing all the rows every night or throughout the day. And so these flow steps that you might solve for one use case, you really can't use them for data that is parked in an index. And so to get around that, we've added support for for script fields. And so this is a feature that was added in experimental mode to, I think it was 5.3, but that's now been widely released for all users within 5.4. So a really good example of when you would use a script field would be something like age. So if you have a field like, let's say we wanted to pull the age of the crime that took place. This is something that is constantly changing. So if something is 10 days old today, it'll be 11 days old tomorrow. And unless I refresh that data all the time, it would be difficult to be able to use the flow step for that. So fortunately, you can use a new script field to evaluate the calculated expression as your users are doing searches. So we have got different builders for different types of script fields. We even have a code file based script field if you've got a code file set up. So we'll do a time between one here, and I'll just call this age. And we will use our date field as the start, and then we'll do now as the end, and we will do it in units of years. So go ahead and save that, and it will add our script field down here. And then when I return to the data and scroll to the right, you see here we've got age now computed for us. So this is all being evaluated on the fly as the users are using the data, either in a pivot or in a chart. You can immediately start using this age field without refreshing. So that is really good for a couple different use cases. One, as I mentioned, time-based values. There's really no other way to do it. But it might also be the case where you want to add a calculation to a data set after it's been indexed. And so you have all the different data elements that you need to be able to do it. Like say you want to multiply two numbers together. You can do that by adding a new script field and immediately get use of it without having to re-index everything. And so if I go to pivot, I can use this field just like I would in the other field. If I go to values and pick age and click average and apply, it'll take just a moment because it's running this across on the fly across all 7 million rows in my index. But hopefully here any second, there we go, it came back. So the average age of our crimes is 11 years. And then I can also break that out just like I would any other pivot table. And so it's using our script field now, just like it would a native data element. So another thing that you'd want to do if you have a really large data set, you'd want to be able to just have one version of it. You wouldn't want to make one version from one group of people, another version for another group, maybe some with sensitive columns and some without. And so we're trying to give you the tools that you need with regard to security to be able to make that happen. So the first one I want to talk about is our row level security filter. So if we go over to Informer, if we go to our teams, I have a team of officers. And within this team, I've got Officer Smith and Officer Jones. And within each one, I've set up a user field within Informer. I can show you that if you go to the admin page and then go to user fields. Here's the beat user field that I made. It's a number. And what I've done is I've assigned different beats to my different officers. And when I go back to my crimes data set and I look at the access tab, I have shared this data set to my officers team filtered by the user beat filter. So let me show you what that looks like. So if we look at our save filters, I created a save filter that is filtering based upon the value of beat on the user's record. And so that's going to be a different value, depending on how the user logs in. I might have beat 111, so it's going to filter based on my 111 or my beat. And another user might have a different beat. So if we go to users and let's go impersonate Officer Smith. So if we look at his record, he's got beat 211. So we will impersonate that user and go to data sets, and we see this is the only data set that they can see. And so now we see that our 7 million rows is now 25,000. And so we're looking at just beat 211. And so all of the filtering that this user does at this point is all going to be based on this implicit filter of my beat. And so that has a couple advantages. One, certainly the security advantage. I'm only looking at data that I'm supposed to see, but it also makes everything that much faster. All my filters are going to go much more quickly. My pivot tables and charts, they're all going to run a lot more quickly because it's looking at much less data. So if we return to our session and then now go to Officer Jones, and then we impersonate this user and go to Chicago crimes, here we're going to see 30,000 rows for beat 111. So that's really nice. Your users are getting different data elements without having to run ad hoc queries with security rules set up. So the second aspect to security that's important when dealing with large data is column level access. And so when we look at this here, I won't be able to go through and do the whole demo. Andrea mentioned this in the previous webinar, but there's now the ability to use data source security to determine field access. And so all I need to do is go over to the data source and go choose the fields that should be restricted. So that would be your social security numbers, your salaries, your PII bits of information. And I can restrict those and then make sure that my security is set up for my different users. And then Informer will keep track of where those fields are used within different data sets, and then we'll honor those same settings as users consume data. So it won't let users pull columns they're not supposed to see. Now you do have to worry about make sure that you don't use sensitive fields within reports as the basis for, say a pie chart where you are showing salary ranges or something like that. You might have content that won't work the way you expect if the users aren't allowed to search that data. But if they're primarily viewing the data within a grid or a pivot or building their own charts and so forth, that column security works really well. All right, so the next trick that I want to talk about is doing incremental refreshes. So if you go down here to the gear within your data set, I don't know, many people probably haven't even ventured this far down, but if you go to this tab, you see there's a bunch of different settings that you can tweak to fine tune how your data is brought in to a data set. And so down here, there's a section on refresh behavior. And when I've got a really big data set that I'm going to be doing incremental refreshes on, the very first thing that I'll do is change it to run on this upsert mode. And so what that means is by default, when you refresh a data set that's running in replace mode, what it does is it creates when you click refresh, it creates a new empty index. And then we run the query and we stream all the data into that index. And then at the end of the refresh, we will change the reference to point to the new index. So users will be able to start seeing the new data. When you put it into upsert mode, what happens is we don't change the index. We're always using the same index each time. And so if you identify an ID field, Informer will use that field as the primary key of the row within the index. And so if a row gets re-selected later, what will happen is it will update that row in the index instead of adding it as a new row. So what I would do is set it into upsert mode, choose what my ID field will be, and you want to make sure that that is a unique field for each row. And that can be tricky if you maybe normalize the data. But then in your selection criteria, what you can do is you can choose selection criteria based on something like a last modified timestamp. Or you could use a created on timestamp if data is just being appended. And then the last element, so there I had selection criteria where I just have a date range, date before, date after, or date before. And the last thing that you would want to do is create a job that uses this last queried at variable as the basis for the start date. And so whenever we run a query, we keep track of the time that we issued the previous query, and then we allow you to feed that timestamp back into the next query. And that way you're reducing the refresh time from potentially days if you're querying multi-million row table to just, a few seconds potentially if it's only a few hundred rows or so that are changing. And so then you can schedule this to run throughout the day and constantly pull data, in. So if the data is not changing, you can really just go by a created timestamp. If the data is changing, you would need to keep track of some kind of last modified timestamp. So that's a way that you can do incrementals. The speed of your query is really important as you're indexing all this data. So there are a couple other things that you can do back here. So one of them is this data buffer size. So this is the number of data records to buffer for indexing as Informer is refreshing a data set. So the way that we bring data into a data set is if we were to just index a record one at a time, it would take a really, really long time to refresh even a small data set. So what we try to do is bundle up batches of records as we stream the data out of the database and then index those batches one at a time. And so you can control the size of those batches by using this buffer size here. And the ideal value is really going to be dependent on the size of each row within your data set. So I encourage you to kind of play with this value to see what works best. Related to that is this worker thread setting. So worker threads allow you to say how many of those batches can be in flight at any time indexing into the engine. And this will default, I think, to 1, but you can bump that as well. So if we take this back down to 1, and then let's change our record size back to, say, 50. And the way that you want to play with these settings is using this benchmark tool. So if you click on the 3 dots and bring up this benchmark, this is we've done some work on the benchmark viewer to make this easier to use. You can actually disable different flow steps one by one. So this is a great way to figure out what the slow spot is. If you're finding that your indexing rate seems slow, you can try out different things. Is it the index? Is it the query? Or is it the flow step? So if I try running this without checking either of these boxes, what I'm testing here is what is the rate that I can get data out of my database. So this is going to be your maximum throughput that Informer is able to achieve without any indexing or without any flow steps. Now, if I run this flow step, this will show me what the best rate is using that flow step. Looks like that's not a very good rate. Let me try to change this to index results. Let's see how this goes. There we go. So by indexing the rows, it looks like we're getting around 700 rows a second here, which is not super great. So let's stop that and close it. And I'm going to come in here and I'm going to change my data buffer size to, say, 5,000 records. And then I'm going to bump my pool size there to 10. And so now let's come in and then we'll benchmark this again. And we'll choose index results. Oops, I think it was because I'm going to get rid of that. and then we'll run it. And so now you see I've really cranked up my, my throughput. So I've taken it from a few hundred rows a second now to around 6,000. And so that's going to make a really big difference in terms of the total amount of time it takes for me to index all this data. And so, you know, these are just some examples of ways in which we've got some tools that you can use to point Informer to some really large tables and build queries that you can then fine tune to run quickly to bring back the data that your users need, and then be able to turn them loose on that data using security rules that you define to make sure they're only seeing the rows and columns that they're allowed to see. And then also setting up background refreshes to keep that data current, as well as being able to ingest it in the first place. So that pretty much takes us to the end of what I was going to show today. So if you have any questions, please enter them into the chat window. But otherwise, I'll let you get a few minutes back today. We're coming in a couple minutes early here. So if you have questions, please feel free to ask. And you know, if we'd be more than happy to either answer through the chat or, you know, get in touch with you if you would like help setting up a similar environment within your organization. So I want to thank everybody for your time today, and take care.